Welcome to the Binary Tree Mastery series, where we turn confusing branches of code into crystal clear solutions. Today we are here with this problem: count nodes equal to average of subtree. So, given the root of a binary tree, return number of nodes where the value of the node is equal to the average of the values in its subtree. Okay, the average of n elements is the sum of n elements divided by n and rounded down to the nearest integer. Subtree of root is a tree consisting of root and its children. Let us understand this problem. The problem says we have to count the number of nodes which satisfies this condition. This condition means the average of subtree we should be equal to the root value of that subtree. Suppose we take this subtree, okay, so this subtree consists of nodes 5 and 6, so the sum of them is 11 and the total number of nodes we have is 2. So 11 by 2 is 5, which is equal to this guy, this the root value, so we can count this as 1. So we can have count equals to 1 for this. Now let us check this subtree. Okay, so this subtree consists of only one element, which is also the root element, so 6, and total number of elements is 1. So the count of nodes is 1 and the average is 6, so this is equal to this. So this is again we can count it, so we can increase the count by 2. Let's check this element, right? So again for this, the total sum of all the elements in that subtree is 1 and the number of nodes is also 1, so this is 1. This matches the value of the root, and so we can increase the count by 1. Let's consider this guy here. So the sum of all the nodes in this subtree is 0 divided by 1. 1 is the only node, this is the only node here, so number of nodes is 1, 0. So this results in 0, which is equal to this here, the root of the subtree. So count increases by 1, so count is 4 now. Now let us consider this subtree here, right? This subtree has 3 nodes. Okay, so the sum of all the nodes is 8 plus 0 plus 1, which is 9, divided by the total number of nodes is 3, which is 3. So 3 is not equals to 8, so we don't increase count. Now let us take the whole tree, the full tree. So the sum will be 4 plus 8 plus 5 plus 0 plus 1 plus 6, which is equals to 24, right? And the total number of nodes we have is 1 2 3 4 5 6, so 24 divided by 6 is 4, which is equal to the root of the tree. So we increase count by 1, so the total count, the answer is 5. So this is our final answer. Now let us see how can we actually solve it. Let us look at this element. Now what do we need here, like what do we need from its children to calculate average? So we would need sum of the left subtree, which is 0 here, and the sum from the right subtree, which is 1 here. So at this point we can calculate the total sum as left tree sum plus uh, right tree sum, left tree sum plus right tree sum plus root value, right, which is 0 plus 1 plus 8 equals to 9. Okay, now to find average, this is not enough. We would also need the total number of nodes which are there in that subtree. So let's pass, along with sum we will also pass the total number of nodes. Okay, total number of nodes. So this left subtree has node 1 and this right subtree also has node 1. So now this count will be left tree node plus right tree node plus 1 because this is 1, this is 1, and this is also one node, so we will consider this as well. So plus 1, so in this case it is 1 plus 1 plus 1, which is equals to 3. So now we have both the sum and the count of nodes, so we can easily find the average. So average will be 9 by 3, which is 3. Now we can easily check if average is equals to this root value, which is not, we will not increase the answer. Okay, now for these root elements, okay, so root will not have any child. So if while traversing we encounter any root which is equals to null, we'll simply return 0 0. Okay, the sum is 0 and the number of nodes it has is also 0. Okay, this left child and this right child. Suppose also from here we will return 0 0, right? So this, now what will this return? This will return a sum of 9, right? 9 and a count of 3 to its parent, right? Similarly we'll do this. So this is null, empty. Okay, so we will return 0 0 from here and we will return 0 0 from here. This we can take as an array or we can use a pair, but for simplicity let's go with an array. Okay, an array of two elements. First will contain the sum and the second will contain the count. So this is also returning 0 0. Now at 6 we will compute the sum and count of this subtree which is under 6. So similarly sum is left child sum which is 0 plus right child sum which is 0 plus the root value which is 6. So the total sum is 6 and the total node count is left child node count is 0. Sorry, this will be 0 1. Sorry, this will be 0 0 0 0. Right child node count is 0 and this 6 means this is one node, so we will add 1, so this is 1. So the average here is 6 by 1, which is 6. Is this equal to this value? Yes, then we will increase answer to 1. This did not satisfy the condition, but this did. Yeah, answer was initially 0. Okay, so we will increment it to 1. Now from here what are we passing? We are passing the sum and the nodes. So the sum is 6, sum is 6 and the total number of nodes is 1. Okay, so now 5 has 6 comma 1 coming from here, and since this the left child is null, so here it will have 0 comma 0. So for 5 we'll find function of 5 sum equals to the left subtree sum, left node is null, so we will have 0 plus right subtree sum which is 6 and plus the root value which is 5 itself, and we have 11. The count of nodes is 0 since the left subtree is null, plus 1 from here and plus 1 for this node itself. So we have 2 and 11 divided by 2 is 5. They have asked in the question to round it down to the nearest integer. It's 5.5, so rounding down is 5 and 5 is exactly equals to this root value. So we can increment answer by 2. Similarly, so 5 will return uh, 5 will return sum of 11 and a count of 2 because it has two nodes beneath it. This is 1, this is 2, two nodes beneath it. This will return this, and finally we will have we'll compute at 4. So while computing at 4 we'll do this left child sum equals to left child sum is 9 plus right child sum is 11 plus 4 which is 24, and the node count is left child node is 3 plus right node is 2 plus 1 which is 6. So 24 by 6 is 4 which is equals to this. Yeah, so we can increase the count by 1. Also this will also satisfy the condition and this will also satisfy the condition. All leave nodes will satisfy the condition because leave nodes will not have uh, any children, and it will always be divided by 1. So whatever the number is, that is the sum and it is divided by 1, so 1. So yeah, 3 leave nodes which is 3 plus 5 is satisfying the condition, 4 is satisfying the condition, so it is 2. Our answer is 5. Let us look at the code how we can solve it. It's a simple code. So this is the main function where we are going to return the count. We will initialize a global variable with answer equals to 0, and we'll have a helper private method find, which will help us find the answer. right? So we'll pass the root value and the return type is int of array. Okay, this array will contain, this array at 0th position will contain the sum of of the children, uh, and the first element will contain the count. Okay, so now we'll define our base case. If root is null, then we are straight away returning 0 comma 0, because there will be no sum and there will be no node as well, so 0 comma 0. Next we will find the left subtree uh, array and the right subtree array, and the sum will be equal to the left subtree sum plus the right subtree sum plus the root value, like we had discussed in our previous slide. And the count will be left subtree count plus right subtree count plus 1 for the node itself, right? And we'll check the condition here. If the average is equal to the root value, then we will simply increment the answer by 1, and we will return this this new array with sum and count to the parent. So let us run this code and see if it's working. Yep, it passed the test cases. Let me submit it and check. Yep, it passed. Happy coding.